All right, everybody, get ready, because today we are diving headfirst into the quantum world. We're talking all about the Higgs boson, but, and this is a big but, we're going off-shell this time.
Yeah, and I know off-shell kind of sounds like we're just trying to use all the fancy physics jargon, but trust me, it's way more than that. Like, we're talking potentially huge discoveries about the universe here.
Okay, so before we jump into this off-shell thing, how about like a super quick recap about the Higgs boson for anyone who might have missed it?
Basically, it's the particle that gives other particles mass.
Right, so it's the reason we're not all just like cosmic dust bunnies or something.
Yeah,
It's
exactly.
been, what, around a decade since they found it? But there's still so much we don't know about it. It's like we found this treasure chest, and we've only managed to open, like, one tiny little compartment.
That's a perfect way to put it. And that's where this whole off-shell thing comes in. It's like we're finding a whole new way to, like, pry open that treasure chest, and see all the other secrets that are hiding in there.
Okay, so imagine you've got, like, a rule book,
Mm.
right? And it's for how the entire universe works.
Yeah.
And that is basically our standard model of particle physics.
Yeah.
And it says pretty clearly that the Higgs boson should behave a certain way, which is in a linear, predictable fashion.
But, and this is where it gets really interesting, what if the Higgs boson is actually like ripping up that rule book? What if it's going totally off script and non-linear?
Whoa, okay, so that's what we're diving into today.
Yes.
We've got actual research that is putting this whole nonlinear Higgs boson idea to the test.
It's a real head scratcher.
Yeah. Like, does this thing play by the rules? Or is it kind of like a rebel in the world of particles?
Think of it like this. Like, you've got this perfectly tuned guitar, right? So you expect it to play a certain note when you pluck one of the strings.
Right, of course.
That's kind of like our standard model expectation.
Mm.
But then what if, and maybe it only happens sometimes, it plays like a completely different note? You'd be surprised, right?
Yeah, totally.
That's exactly what it would be like if the Higgs boson is nonlinear, like that unexpected behavior.
Yeah, okay, yeah, that is a serious plot twist.
Yeah.
But how do you even start to study something like that? It's like, I don't know, trying to catch a moonbeam in a jar.
Well, it's actually really clever. Scientists are looking at how the Higgs boson decays. You see, when it winks out of existence, it doesn't just disappear, it actually transforms into other particles,
Oh.
like pairs of Z bosons, for example.
So those are like the trusty sidekicks in our particle physics story?
Yeah,
Yeah.
exactly. And so by studying this whole decay process, especially when those Z bosons are also acting a bit weird, that's the off-shell part, we can actually catch a glimpse of the Higgs boson's, its hidden behavior.
So we're using these other particles, these Z bosons. They're like our spies in the quantum world.
Yes, exactly. It's pretty cool. It's like how detectives, they'll listen in on a suspect's phone calls to try and get evidence. We're basically doing the same thing. We're using these conversations happening between the Higgs boson and these other particles to see if it's acting even a little bit suspiciously.
Oh, this is good. So we've got our rule book, we've got our rebellious Higgs boson, and we've even got our particle spies. So where does this research go next?
Well, there are these two competing theories, right? They're like two possible explanations for what might be happening. One of them, it's called SES-MFT. It basically says, nope, the Higgs boson is playing by the rules, everything is fine.
Okay, what about the other theory?
This one's called AFT, and it says, hold on a second, there might be way more to this Higgs boson than we originally thought. And HEFT is totally open to the possibility of nonlinear behavior, which we've been talking about, and that could point to a whole new world of physics.
So it's SMFT versus AFT in a cosmic showdown.
I guess you could say that.
I am here for it. Okay, so where were we? Oh, yeah, is this Higgs boson a rule follower or, kind of a rebel? Like, what did they actually find?
Well, you know how we talked about those off-shell measurements. Basically, we're listening in on how the Higgs boson interacts with other particles, right? So this research, it took all those measurements and it compared them to what we would expect to see if the Higgs boson was acting linearly, like SAMI-FS says it should.
So are we talking like rewriting textbooks here? Did they, like, catch the Higgs red-handed, completely breaking all the rules?
Well, not exactly. I mean, it's not like a done deal or anything, but the findings are they're intriguing. The research kind of hints that while the Higgs boson mostly seems to follow the rules, there might be a little bit of wiggle room for it to act a bit, nonlinear.
Wiggle room, huh?
Yeah.
So you're saying there's still a chance, like a real chance, that this thing could be a little bit of rebel?
That's the exciting part, isn't it? It's like we've been studying this particle for years, right? And we thought we had it all figured out. And then this research comes along and it's like, hold on a second, guys, we're not done here.
I can definitely see why you're so into this stuff. But okay, let's bring it back down to Earth for a minute.
Mm.
For those of us who, aren't particle physicists or whatever, why should we even care if this thing is breaking the rules? Like, what's the big deal with the Higgs boson being a little nonlinear?
Honestly,
Yeah.
this tiny little particle, this Higgs boson, it could be the key to some of the biggest mysteries in the entire universe.
Okay, now you've got my attention.
So for starters, let's talk about dark matter.
Okay, yeah, I heard of it.
Right, this mysterious stuff that makes up, like, a huge chunk of the universe,
Mm-hmm.
but we can't see it. We can't even interact with it directly.
Yeah, it's like the universe's biggest secret.
Exactly. Now imagine if those nonlinear behaviors that we're talking about, what if they're actually hints that the Higgs boson is interacting with something that we haven't discovered yet? Something that could be, dark matter.
Wait, are you serious? You're saying the Higgs boson could be like our bridge to finally understanding dark matter?
It's a possibility, yeah, and it's a really exciting one.
That's huge.
And it doesn't stop there. This research, it also has big implications for understanding dark energy, that force that's making the universe expand faster and faster.
Okay, my mind is officially blown. So this one tiny particle, the Higgs boson, it could be the key to both dark matter and dark energy.
We could be talking about changing our whole understanding of the universe as we know it. That's why these findings are so important.
This is amazing. So where do we go from here? What's next for these physicists?
Well, for one, we need a lot more data. The Large Hadron Collider, where they discovered the Higgs boson?
Oh yeah, the giant particle accelerator.
Right, that thing, it's actually getting a major upgrade right now.
Upgrades? What kind of upgrades?
It's like giving the whole thing a massive power boost. These upgrades mean that scientists can smash particles together at even higher energies than before.
Okay, and why does that matter?
Because when you smash particles together at really high energies, guess what you get? More Higgs bosons.
Oh, I see.
And the more Higgs bosons we have, the more we can study, the more data we can collect, and the better we can understand if these nonlinear behaviors are actually happening.
So it's like we're getting, a sharper lens to look into the quantum world with?
Exactly. But it's not just about getting more data. We also need to improve our theoretical models, figure out new ways to analyze the data, and maybe even rethink some of our most basic ideas about how the universe works.
I love it. There's always something new to learn. So before we finish this part of our Higgs boson deep dive, what's the main thing you want our listeners to take away?
I think it's this. This one little particle, the Higgs boson, it has the potential to unlock some of the biggest mysteries in the universe. This research is really just the beginning. Trust me, there are a lot of surprises in store for us.
You can say that again. And we are back for the final round of our Higgs boson deep dive.
Round 3, let's go.
We've gone deep into the quantum world. We've talked about this whole rule-breaking Higgs idea. And now it's time for the big question.
What does it all mean?
Yeah, exactly. Like, we've talked about some seriously mind-blowing stuff here. But how does it actually, affect things? If this Higgs boson is really out there talking to all these hidden particles, does that change anything about our lives? Should we be, wearing Higgs-proof helmets or something?
I don't think you need to worry about the helmets just yet. But you're right, this research could totally change how we think about, everything. Remember how we were talking about those, gaps in the standard model? Things like dark matter and dark energy.
Yeah, those are pretty big gaps.
This isn't just about, adding a new sentence to a physics textbook. This is about the possibility of finding totally new forces of nature,
Yeah.
fundamental building blocks of the universe that we never even knew existed.
Okay, so I probably don't need a new helmet. But maybe I should invest in a bigger bookshelf for all the new physics books that are going to be coming out. So are you saying this is as big as when we discovered atoms? Or figured out that the Earth goes around the sun?
It could be even bigger than that. Think about dark matter for a second. If the Higgs boson is really interacting with it, even indirectly, that means that dark matter isn't just this, separate thing. It's a core part of how particles get their mass. And that means it's essential to how everything, literally everything we see around us, is made.
So instead of just being this invisible thing, hiding out in the universe, dark matter is more like a secret ingredient in the recipe for, galaxies, stars, even us.
Exactly. It changes everything. And then there's dark energy, the thing pushing the universe apart faster and faster all the time. If the Higgs boson, the thing that gives things mass, is somehow connected to the thing making the universe expand, well, that could completely revolutionize how we understand the entire universe.
Wow. I mean, it really feels like we're standing at the edge of this whole new world of knowledge, ready to explore. Where do we even start? What are physicists doing to, keep going on this journey?
The upgraded Large Hadron Collider, that's going to be huge. Imagine trying to listen to someone whispering in a really loud room. You need a really sensitive microphone to hear them, right? That's what these upgrades are like. They're giving us a much clearer signal so we can listen to what the Higgs boson is trying to tell us.
And with a better signal, who knows what we'll find? Maybe we'll finally get to see what's on the other side of that door the Higgs boson seems to be guarding.
Exactly. But it's not just about having the best equipment. This research shows us that we need to be creative. We need new ideas, new theories, and we have to be open to the possibility that everything we thought we knew might be wrong. It's a challenge for everyone in physics.
I'd say it's more like an invitation, wouldn't you? Like the universe just handed us this incredible treasure map, and now we all get to go on the adventure together. So as we wrap up our deep dive into the world of the off-shell Higgs boson, what's the one thing you want our listeners to remember?
Remember that feeling of pure wonder that you get when you discover something new, that excitement of exploring the unknown. The universe is full of mysteries, and sometimes the tiniest things can lead to the biggest discoveries. So keep asking questions, keep exploring, and never lose that curiosity.
I love that. And on that note, we'll leave you to ponder all the amazing possibilities out there. Thank you so much for joining us on this incredible journey to the heart of particle physics. We'll be back next time with another deep dive into the most fascinating corners of the universe. Until then, keep looking up.